Brace yourselves for a cosmic cataclysm of unprecedented proportions. Betelgeuse, the red massive megastar, poised on the edge of our galaxy, is sending ominous alerts through the universe. The usage of the James Net Space Telescope astronomers have exposed something profoundly unsettling about this giant celestial frame, as renowned astrophysicist Brian Cox troubles a grave warning. The query looms: are we at the precipice of witnessing a catastrophic supernova explosion that would forever alternate the nighttime sky as we know it? Permits dive in the grand tapestry of the cosmos in which stars are born, stay, and die in staggering fashion. One famous person has recently captured the imagination and problem of astronomers and the public alike. This celebrity is Betelgeuse, a red fantastic, large, of significant proportions and age, situated conspicuously in the constellation Orion. Its different reddish hue and variable brightness have long been a source of intrigue, but recent tendencies have intensified interest on this celestial large. We discover the nature of Betelgeuse. We find ourselves on the cusp of a probably huge occasion inside the existence cycle of this big name. But what may want to these changes in Betelgeuse characterize? Are we witnessing the prelude to a cosmic spectacle of unimaginable scale? Betelgeuse, approximately 764 instances large than our solar, is a stellar behemoth. Its enormous length is almost past human comprehension. Consider a star so huge that were it to update our solar, its floor would expand past the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in its stellar include. This amazing size is not simply a testimony to Betelgeuse's physical attributes, however, additionally speaks to its degree within the stellar lifestyle cycle as a pink, incredible, massive. Betelgeuse is in the twilight of its life, a section characterized with the aid of enlargement and cooling following a existence spent fusing hydrogen into helium in its middle. However, what about the age of Betelgeuse? This star, believed to be around 88 to 8.5 million years antique, is tremendously young in human phrases, but historic within the context of stellar lifetimes. Its contemporary red, amazing, massive phase is the culmination of hundreds of thousands of years of stellar evolution, a period marked by way of dramatic adjustments and techniques which have converted it from a hot blue superstar to the pink massive we see nowadays. The lifestyle cycle of stars like Betelgeuse is a tale of transformation driven by way of the relentless forces of nuclear fusion and gravity. Betelgeuse's one-of-a-kind reddish hue is some other hallmark of its modern-day level. The crimson shade is an end result of its fantastically cooler surface temperature in comparison to different stars like our Sun. At the same time as the solar floor temperature is about 5,500 Kelvin, Betelgeuse's cooler surface registers temperatures around 3,500 Kelvin. This cooler temperature lets in Betelgeuse to emit mild at wavelengths that supply it a purple look. However, this shade is not just a visible trait, it provides clues. Approximately the star's physical situation and the method is happening inside its significant gaseous expanse. Adding to Betelgeuse's mystique is its historic color. Trade, historic Roman and Chinese language writings propose that around 2,000 years in the past, Betelgeuse became yellow. It turned into simplest in the 9th century. That Arabic pupils first described it as pink. This color shift over human history is not only a element in the annals of astronomy but a clue to the celebrity's evolutionary path. The variable brightness of Betelgeuse is another fascinating issue. It's a semi-regular variable celebrity, which means its light periodically waxes and wanes, and this variability is a characteristic dance of luminosity that has involved astronomers and sky watchers for centuries. Generally, Betelgeuse undergoes a 400-day cycle alongside an extended cycle that stretches about 5 years. These cycles had been documented as some distance lower back as 1836, via Sir John Herschel and probably even earlier in Aboriginal oral traditions. But what makes Betelgeuse absolutely enigmatic is not just its converting brightness but irregularity. Not like many stars that follow a predictable sample view, once in a while deviates from its rhythmic dimming and brightening, hinting at complicated and much less understood tactics going on inside its gigantic form. Current groundbreaking revelation: Betelgeuse captured the attention of astronomers and stargazers international with an unexpected and dramatic alternate in its look, an occasion now famously referred to as the first-rate dimming in overdue 2019. The red top-notch large Betelgeuse, one of the brightest stars within the nighttime sky and a distinguished function of the Orion constellation, commenced to mysteriously dim. The celeb's dimming was so pronounced that it started out dropping its luminosity at an common price of 0.01 magnitudes, in keeping with day, attaining its lowest brightness in February 2020. Betelgeuse, typically seen to the bare eye even in mild, polluted regions, became markedly fainter, a exchange substantial even to newbie observers. However, there is one problem with trying to display the pastime ities of Betelgeuse: the time paradox. When we observe a celeb like Betelgeuse, we are not seeing it because it exists within the present, but as it became in the beyond, due to the time it takes for mild to travel to us. In Betelgeuse's case, at about 725 light-years away, the light we perceive today left the famous person almost 7 even centuries ago. This time lag makes it difficult to expect and monitor surprising changes in a star's conduct, as we're essentially peering into its past. The Betelgeuse dimming event served as is a reminder of the inherent problems in real-time astronomical observations and the constraints of our expertise whilst handling the sizable cosmic scales and the time paradox they introduce. The unfolding of Betelgeuse's celestial drama became closely monitored via Andrea Dupree, accomplished director of the Middle for Astrophysics at Harvard and Smithsonian, and her group. They applied Hubble to research the behemoth big name as a part of a 3-year study to reveal versions in Betelgeuse's outer environment. Those observations have provided a completely unique insight into the dynamics of a variable star like Betelgeuse, which often expands and contracts, causing fluctuations in brightness. Hubble sensitivity to ultraviolet light allowed the researchers to probe the layers above the star's floor, which had been heated partly with the aid of the celeb's turbulent convection cells. Similarly, evaluation of the Hubble spectra taken at exceptional factors at some stage in 2019 and 20120 helped in measuring the movement of cloth in Betelgeuse's outer atmosphere, due in precise the spectra targeted on magnesium-2 traces that are indicative of the star's atmospheric situations. These observations showed cloth shifting at speeds of about 200,000 mph from the superstar surface into its outer ecosystem. This warm, dense fabric sooner or later extended thousands and thousands of miles from Betelgeuse and turned into the precursor to the dirt cloud that led to the celebs dimming. Dupree and her crew anticipated that about twice the ordinary amount of fabric from Betelgeuse's southern hemisphere was lost over the 3 months of the outburst. This mass loss changed into big, especially thinking about that Jew, like any stars, continuously loses mass, albeit at a rate a ways extra than that of our sun. The scale of this mass ejection and the
subséquent d'immenses parcs discussion
amongst astronomers about whether this event could be a precursor to a supernova explosion. The proximity of Betelgeuse, about 725 mild years from Earth, adds to the intrigue, as this type of explosion would be visible from Earth and, as its nuclear gas was exhausted, the outer layers rebounding off the dense center in a mind-blowing center fall apart. Supernova. But what makes SN 2023 ISF in particular fascinating is the dense shell of gas that evolved, significantly impacting the breakout of the shock wave from the star's middle. Viable situations ought to explain this. Dense circumstellar cloth. Either a sturdy regular wind had been shedding material from the big name before the explosion, or the famous person experiencing random outburst hurling fabric into space DOI. In either case, it's estimated that the superstar misplaced as much as a sun mass of cloth in the final 1 to 2 years of its existence, indicating that its very last moments were whatever but serene. Identifying the progenitor of SN 2023 ISF has grown to be a focal point of have a look at through various methods and facts sets. Researchers have converged on a probable candidate, a purple, amazing large SU, by analyzing the details of SN 2023 ISF's explosion, inclusive of its progenitor's traits and the mechanisms main up to its final detonation. Astronomers can refine their models of stellar evolution and supernova mechanics. Those insights without delay tell our expertise of Betelgeuse's contemporary state and its capability course to supernova, imparting a clearer photo of what signs to search for and how to interpret the huge purple giant's complex behaviors. However, whilst will Betelgeuse explode into a supernova? Research from Japan's Tohoku University has cautioned that Ju may presently be within the carbon-burning stage of its existence, a segment that commonly precedes the end of a celeb's existence. The chief of this examine posits that the celebrity's center ought to disintegrate some tens of years after the carbon is exhausted. Conversely, researchers from Hungary's Observatory believe Betelgeuse is in an advanced helium-burning degree. Notwithstanding these differing perspectives, there's a consensus that Betelgeuse is probable to be the next supernova inside the Milky Way, even though this event might not occur for every other 100,000 years. Traditionally, observations of supernova have provided helpful insights into stellar deaths. The earliest confirmed report of a supernova courting return to 185 CE become discovered as a shiny megastar that took approximately 8 months to fade from the sky. When you consider that then several huge supernova have been recorded, including SN 16, the brightest recorded celebrity ever to seem in our nighttime sky, visible throughout various components of the arena, and SN 1054, which resulted in the formation of the Crab Nebula and become visible in daylight for 23 days. The most latest supernova discovered inside the Milky Manor become SN 1987A in the large melanic cloud observed within hours of its mild accomplishing Earth, marking the first supernova detected through neutrino emission and discovered throughout each band of the electromagnetic spectrum. Those observations had been critical in developing successful models of supernova behavior and know-how, their role in celebrity formation. So what if the night sky abruptly burst into a fantastic display of cosmic fireworks, charming our gaze with the radiant explosion of a celeb? Imagine for a second the as soon as acquainted constellation of Orion, decorated with an unusual blazing jewel ballast, one among its distinguished stars, transformed into a exquisite supernova. Ought to this or inspiring occasion impact Earth in any manner? Betelgeuse's imminent supernova is categorized as a core collapse supernova, a sort of explosion that takes place when huge stars exhaust their nuclear fuel and may not aid their very own gravitational crumble. Core collapse supernova are among the maximum active and cataclysmic occasions in the universe. When Betelgeuse eventually goes supernova, it'll release as much strength in a relay of seconds as our sun will emit over its entire lifespan of billions of years. The energy output from a supernova more often than not takes the form of electromagnetic radiation along with visible light, X-rays and gamma rays, but the maximum instant and visible effect of a Betelgeuse supernova might be a surprising mild show in our night sky. The explosion might, in short, outshine the moon and could be visible even during the day. Imagine watching up at the daytime sky and witnessing a second, rather brilliant sun seem. For some weeks or maybe months, the occasion could be a panoramic celestial show, fascinating astronomers and stargazers alike, but as fascinating because the visible spectacle of a bulge supernova would be. Its real importance lies within the scientific opportunities it offers. Supernova, especially those of huge stars like Ju, are cosmic laboratories that offer helpful insights into the essential workings of the universe. One of the instant blessings of staring at a bulge supernova might be the opportunity to witness the very last degrees of stellar evolution up close. While large stars like Betelgeuse explode, they distribute elements solid within their cores, inclusive of heavy factors like iron into area. This manner is responsible for enriching the universe with the building blocks of planets, stars, and life itself by way of reading the spectroscopic signatures and the distribution of those elements. In the aftermath of a supernova, scientists can advantage a deeper information of the way stars evolve, fuse elements, and contribute to the formation of latest celestial bodies. This expertise is important for unraveling the records and composition of the universe. Even as the seen light from a bulge supernova might be astonishing, and equally fascinating element of the occasion is the emission of neutrinos. Neutrinos are subatomic debris that are notoriously tough to come across because they not often have interaction with but in the intense surroundings of a supernova they may be produced in massive portions. These elusive neutrinos offer a unique window into the heart of a dying big name. They are able to offer statistics about the center crumble method, losing mild at the essential forces and particles at work for the duration of a supernova explosion. Detecting and reading those neutrinos might be a momentous scientific achievement, doubtlessly unlocking secrets and techniques about the universe's maximum extreme environments. The remark of a Ju supernova could also have implications for our understanding of the universe's growth and the enigmatic force acknowledged as darkish power do within the past 90s. Observations of distant supernova led to the discovery that the enlargement of the universe is accelerating, not slowing down as formerly concept Betelgeuse supernova being relative near in cosmic phrases would offer a treasured statistics factor for reading the expansion fee of the universe and the function of dark strength. In using it could assist refine our knowledge of these fundamental cosmological ideas, probably revealing new mysteries approximately the fate and nature of the cosmos. But what can be the potential outcomes of a Ju supernova in the world? Is humanity in chance? Thinking about the considerable distances that separate us, this is a not likely opportunity to put the scale of our universe into angle. Consider that 1 light-year is more or less 5.88 trillion miles. Betelgeuse at 725 mild-years away is more than 4,267 trillion miles distant from our planet. This significant separation offers a diploma of cosmic insulation, and any direct bodily harm to Earth from the explosion itself is extraordinarily unlikely.